In this video, we have two radical equations to solve. We also want to confirm the answer, so we want to check the solution. Now, one of the reasons you always want to check radical equations is because of this case here. Yeah, I can say that -1 does not equal to +1. But if I square both sides, I get 1 does equal to 1. And this, of course, applies when you're dealing with square roots. Always want to check your solution anyway. Very important to check when you're dealing with square roots. Because anytime you square both sides of an equation, it introduces what's called extraneous roots. That is, solutions that will work for the squared equation, but won't work for the original equation, which is the one you're solving. So it's pretty straightforward when you have an equation with a single radical. So here we have x equal to 8 square root of x. You want to start by eliminating the radical by squaring both sides. So this gives me x squared is equal to, and then we square this out, 8 squared is 64. And then radical x, or the square root of x squared, that eliminates the radical, so we get this. Now we've got a basic quadratic. Bring the 64x over, makes it a minus 64. Same thing as adding negative 64x to both sides. You get a quadratic equation, and these can be solved either by factoring, quadratic formula, completing the square. Easiest way to solve a quadratic is to factor it, if it factors. So here we have it, one side 0, so I factor out an x from this side, leaves me with x minus 64 equals 0. Once you have it factored, one side has to be 0 now. The product of two factors is 0 if one or both factors are 0. So you set each factor equal to 0 and solve each equation. So we got x equals 0, obviously already solved. If x minus 64 is equal to 0, that of course implies that x has to be 64. Add 64 to both sides, we get x equal to 64. So these are the prospective solutions, but then you have to go back and plug it in. So always go back to the original. See, let's get a check here. If you plug it into this equation right here, or this equation here, or this equation here, it's going to check there. But it may not work for the original equation. So come back up here and put a 0 where the x is. This side is 0, put a 0 over here. On the right side, square root of 0 is 0, and 0 times 8 is 0, so I get 0 equals to 0. So I know that x equal to 0 is the solution. And then we try 64, put a 64 here, where the x is. Always go back to the original equation. Put a 64 here where the x is. 64, square root of 64 is 8. 8 times 8 is 64. So I get 64 on both sides. That's checks. So my solution for this one then is x can be 0 or 64. So that's the solution for that one. Now if your equation has two radicals or more, then you start by isolating one radical. It doesn't matter which one. So I'm going to isolate the square root of 2x plus 3. And then I'm going to add the square root of x plus 1 to both sides. So it's going to cancel it here and put it on the other side. So it's 1 plus the square root of x plus 1. And you start off just like we did the first one. We have one radical isolated. So we can get rid of it on this side by squaring both sides. So then I can, okay, let's square both sides here. Square this side. So on the left side, you have the square of radical 2x plus 1. That just multiplying this thing by itself, so it cancels the square root. I just get 2x plus 3. And then on the right side, I square this out. That's just like squaring an a plus b. So what is a plus b squared? A binomial. Treat that as a binomial. A plus b times a plus b, no matter how you multiply this out, it's the square of the first term, double the product, so it would be plus 2ab plus b squared. So you can set this up as 1 plus radical x plus 1 times 1 plus radical x plus 1 and do the multiplication. Or if we follow this formula right here for a binomial, this is two terms, so we can treat it like a regular binomial. The square of the first one, that's 1 squared. Then let's double this product, so it's plus 2 square root of x plus 1. And then it's plus the square of this second term. Well, it's the square root of x plus 1, so if you square it, it just eliminates the radical. So this gives me x plus 1. So now, we still have a radical here. So again, we just repeat the procedure. We isolate this one. So everything else that doesn't have a radical expression here, we take it over. So I have an x there, and a 2x over here. Let's bring this one to this side over here. Change the sign and combine it, so 2x minus x will give me an x. Get rid of that one, and I have 1 and 1 on the right side is 2. Bring it over to the left side, that's a minus 2 then, when you bring it over. Gives me a 1. So this gives me then, leaves me on the right side with 2 times the square root of x plus 1. I repeat the procedure. In order to solve it, I want to square both sides. It's not going to work if you don't bring everything over. You want to isolate it. So square this here, and then square this. X plus 1 squared, that's a binomial. So I can use this formula here. So it's the first term squared plus double the product. 1 times x is x times 2. So it's 2x. And then the 1 squared is 1. And on the right side, when I square this side, I have to square the 2, so this will give me a 4. Then squaring the radical eliminates the radical, it leaves me with x plus 1. And then I multiply that out, and I put it here on the right side. This gives me a 4x plus 4. No more radicals. So now it's just a regular equation. Looks like it's going to be a quadratic here. Take this over, that's minus 4x, so this becomes x squared. Change the sign of the 4x, minus 4x is going to be minus 2x. That 4 comes over, minus 4 and 1 is minus 3. And on the right side I'm left with 0. It's a quadratic then. I want to try to solve this for x. First we try factoring. If the factoring doesn't work, then you can go to the quadratic formula or completing the square. This one factors into x minus 3 and x plus 1. Once you have it factored out, one side equal to 0, we set each factor equal to 0. So x minus 3 can be 0, or x plus 1 can be 0. So we added 3 to both sides here for the first equation, and I'm going to get x is equal to 3. Or, and on the next one here, add negative 1 to both sides to solve for x. This cancels here, I get x equal to negative 1. So two possible answers for this one, 3 and negative 1. But again, anytime you square, you solve a radical equation that involves square roots, there's always the possibility that you introduce extraneous roots. So you want to check your answer. So let's check for the 3 first. So let's put 3 right here where the x is on the left side. So 3 times 2 is 6 and 3 is 9. Square root of 9 is 3. Minus, let's put a 3 here. 3 and 1 is 4. The square root of 4 is 2. 3 minus 2 is 1. So the 3 checks out. Now we put in a negative 1. So put a negative 1 here where the x is. Negative 1 times 2 is negative 2, and 3 is 1, and the square root of 1 is 1. Put a negative 1 here in the second radical here. Negative 1 and 1 is 0. Square root of 0 is 0, so I have 1 minus 0 equals to 1, and that's what I have on the right side. So that one checks out. Now had it turned out that it doesn't check, or when you plug in one of the values for the solutions into the equation, one of them comes out to the square root of a negative number, then that one's not going to check. So that had happened with the -1, then you would just say reject this one, and your answer would just be 3. But in this case, both solutions would check. In some equations, it might be that just one would check, or it could be that none of them would check. So let's look at something you might have. Say you have x minus 2 is equal to a -3. Now right away, you should know that this one has no solution. But let's suppose you didn't see that, and you would square both sides. So I square the left side, and I get x minus 2. Square the right side, and I get 9. Solve, add 2 to both sides, we get x equal to 11. And let's say you didn't check your answer, you would just say, okay, the answer is x equal to 11. But notice here, if you plug it back in here, 11 minus 2 is 9. The square root of 9 is a positive 3, not a negative. So this one has no solution. Anytime you have the square root, you have some kind of quantity here, unless it has a negative here, this is always understood to be the positive square root. Normally you think of numbers as well. When using the quadratic formula, you get x equals a plus or minus the square root of 9, 3 or -3. But if it's not indicated, this is always understood to be a positive square root. So when you start with this here, this is saying positive square root of whatever this is. So if this is a positive square root, it cannot equal to a negative number. Okay, just an additional info for this type of problem. But in this case, there's your solution for this one. Thanks for watching. We'll see you next time.